So, welcome to another installment of our Simulation September webinar series. Glad you guys could join us this morning. Happy Wednesday to you. It's a beautiful day here in Spokane. I'm happy to be a presenter for you guys once again on our webinar series. So, if you haven't met me before, my name is Brandon Atkins. I'm one of the senior application engineers with Hawk Ridge Systems. Give you a little background about myself here in a moment, but I did see some familiar names on the list there, so glad to have you guys with us here today. I will also be joined by a special guest at the end of the webinar. I'll introduce him when we get there. He'll tell you a little bit more about some simulation specific resources that you guys have available to you now. So I'm going to spend about the next 25 to 30 minutes going through a little bit of introduction to SOLIDWORKS flow simulation. So for those of you that maybe have not taken a look at the flow simulation software, or maybe it's been a while since you've done so, this should be a good introduction for you guys to really get familiar with kind of some of the basics on how it works and potentially how you might be able to put it to use for the day-to-day in your business. So we'll get going with that here in just a moment. If you haven't had a chance to meet me before, a little background on myself. As many of you guys know, Quest Integration recently became part of the Hawk Ridge Systems family. So I was with Quest Integration for just over 10 years as an application engineer with the team there. Recently joined Hawk Ridge Systems and get to continue on with some of the things that I really enjoy doing, and that's helping our customers learn as possibly can about solutions that we offer. So always a lot of fun for me to work with companies around the Northwest, and I get to continue doing that. So on the personal side, I grew up in Montana. I was born and raised in Great Falls. I've called Spokane my home now for about the last 19 years, but many times throughout my career, I've gotten to go back to Montana for work, which is always enjoyable. Get to take some vacations over there with my family. I've got an 11-year-old daughter and my wife there. You can see a couple of pictures of us. We love to do anything outdoors, kayaking, fishing, camping, just hiking around, exploring the area. We're fortunate enough to live in a great place to do that. So always enjoy getting out there. Always enjoy exploring some technology. You can see that my daughter got a chance to play around with SOLIDWORKS apps for kids there a couple months back, but always a lot of fun for us to do that kind of stuff. In addition to that, I occasionally enjoy making a nice batch of homebrewed beer. If you guys didn't know that, now you know a little bit more about me. Being in Spokane, pursuing mechanical engineering technology as an education path, I went to Eastern Washington University right here in the area, just down the road in Cheney. I've been working at Quest pretty much ever since. And one of the opportunities that I had early on in my career was to pursue as many certifications from SOLIDWORKS as I possibly could, which I got a lot of enjoyment out. I got to learn many products like flow simulation, which we're going to talk about today. But that's been one of my primary focus there over the years, is just helping you guys to learn what you can and provide a next level support for you to get up to speed with those solutions. So a bit about what I do. On the agenda for today, as I mentioned, as many of you guys know already, we're going to discuss SOLIDWORKS flow simulation, our computational fluid dynamics utility inside of SOLIDWORKS. And I'm going to start first by just giving you a brief introduction or an overview of some of the capabilities of the software so you can get a nice cross-section of that. And then we're going to jump into a couple of introductory examples just to get you familiar with some of the things that are particularly handy with this solution to be able to iterate your designs very quickly. And most of you guys probably know this already. The main point behind having an integrated simulation tool is so that we can very easily iterate upon our designs and build less prototypes, right? If we're getting right down to why this is important, it helps us to do some of that very quickly within our CAD interface, which I know you guys all enjoy. As we go through some of those examples, you'll see plenty of specific application of the tool, some different ways that you can set up studies and so forth. And then I'll show you just a broader cross-section of different industry applications which is always fun to take a look at. We always used to joke around back in the day that CFD does not stand for colorful flow diagrams, which we kind of get out of the system. They're always really interesting to look at, but it's going to give us some very important information about how our designs perform, and that can be across a very wide range of industries. Toward the end, I'll give you guys a chance if you happen to put any questions in the chat window. I'll go through some of those at the end and make sure we get some questions answered for you guys. So let's start with a quick overview. One of the first things that I like to point out, the way that I like to think about SOLIDWORKS flow simulation, is this is really a general purpose CFD tool. So when we talk about what it can do, we'll go through a couple of specific examples here as we kick things off. So being a general purpose CFD tool, it's very well suited for SOLIDWORKS user to be able to get in and analyze things like internal or external fluid flow, as well as heat transfer. So one of the main benefits, you guys have seen this already, it's integrated in your CAD interface. So I don't have to jump back and forth between different software interfaces to keep things going and move quickly with design iteration. You have a huge advantage there, just being able to stay within the same application. Once we've gotten to that point and we've kind of figured out how we want to iterate our design, which you'll see some examples of this here in just a bit, it's very easy for us to go through and, for example, fill out a table specifying our variables, how we want to change those variables, and ultimately how we want our design to perform. That's really easy to do, all from within the CAD interface. As I mentioned before, this is a utility we can use for internal as well as external flow scenarios. So we see a couple examples there. And we can get pretty complex with different behavioral types that we can handle in the software. So this may come down to, some complex scenarios with compressible or incompressible fluid flow. This may come down to using different fluid types, even non-Newtonian fluids. We may have some examples where we want to take advantage of material models like that, and some other complex behaviors, like maybe we're getting into some more turbulent types of flow, maybe we're handling laminar flow or combination. That's all kind of up to you in terms of how you want to handle those. I also mentioned before, heat transfer is part of the capabilities that flow simulation is well suited for. And I would say that's one of the areas where I get the most questions when folks are investigating this solution, is how it handles heat transfer simulations. So we will go through a couple of examples there. If you've got rotating components that affect your fluid flow, we can also handle those. Things like an impeller, different pump situations. You may have some analysis use cases for that type of thing. And then as of the last couple of years, we've been able to integrate free surface flow. So some super interesting results we can get out of it for things like tank models, analyzing some of this with respect to time if we wish to do so. So you see a quick little animation of that. I know I was super excited when free surface was introduced a couple of years ago, and I've been able to work with it a little bit. The other one that often gets overlooked that I really like to point out is the integration between the CFD tool and the finite element analysis tool, SOLIDWORKS simulation. So if I were to take something like fluid pressures or thermal results from SOLIDWORKS flow simulation, I can actually port those over to the FEA tool. You'll see how that works later on in the presentation, but this can be super handy to just, save a lot of time in analyzing things like stresses and displacements that are a result of those fluid pressures or thermal conditions. I can combine the tools very easily together. So overall, handling some of those multiple physics type scenarios, being able to handle some complex types of behaviors, just a general way to think about this, it can handle a lot of those capabilities very easily. More importantly though, for you as the SOLIDWORKS user, you're able to get in and sort of test drive the performance of your design very quickly and iterate upon those based on some decision making that you're doing within the simulation tool. Now on to a couple of examples. We'll look at a couple of heat exchanger type modules where we're going to utilize different strategies within the software. So for this first heat exchanger, we've got 3-channel flow that we're analyzing. We have a known mass flow inlet of water in this case, and we have a known outlet condition, open to atmosphere. And what we're gonna do is actually try to set up a scenario where I can balance the fluid flow through each one of those channels to get optimal performance for cooling in this case. So I've got a couple of heat exchanger models within each of those channels, and you can see that we kept it very simple just by modeling kind of a block in between each of those. Now, that's not to say that that's the actual geometry that I would use on the finished product, but it's a representative of how the fluid is going to behave when it's within that section of the heat exchanger. What I can do with that, and you'll see this later on, is treat those as sort of a porous media where I'm going to filter fluid of whatever type through that heat exchanger material. Then I've also got these regulator flaps, and what we're going to do is try to figure out the optimal angle of each of those flaps to where I can adjust for a specific mixture or a balanced mixture of fluid downstream. So easy enough to do. The principle is all there. What it really comes down to is trying to figure out what is the angle of each of those regulator flaps to help us balance the flow. That's really what we're after here. To kick things off though, what I typically recommend is beginning with an experimental setup. So we're just going to kind of get things going in an experimental model of that heat exchanger and make sure that we can get what we expect for results and behavior out of the system. So even though I've been using flow simulation for about 10 plus years now, I'm one of the instructors here for this product, I still leverage some of the tools that'll help make it easy for me. Things like, using the wizard to set up my analysis, where it just helps you make sure that you're checking all the boxes and you didn't skip any steps. So we'll pick our analysis type, pretty straightforward to do there. We're going to add things like our project fluids, which may be one or it may be multiples, as you've seen in examples on previous slides here. So in our case, internal flow with water. Now on to our boundary conditions. Very simple, very straightforward, just by interacting with the model itself, things like picking faces or bodies to define some of those boundary conditions. Really simple to do. So I just pick the faces that I want to treat for inlet or outlet. And we're also going to associate some goals with those locations in our analysis that we set up. So for example, I'm interested in monitoring mass flow rate through each one of those channels. So I'm going to do so by setting up goals at specific locations within the model. Something that's really important to think about and something that we touch on pretty heavily within the training modules for flow simulation, why those goals are important. Really what it comes down to is I want the analysis to give me something specific. That's the whole reason that I got into it in the first place. So define those goals ahead of time, and we're going to get some output that's important to us as we move along. Now, I mentioned before that simplified geometry was kind of part of this equation too. Using those heat exchanger substrates, we can go through and define those as a specific material model type within the software. So you've got an extensive engineering database where I can go through and define those porous media behaviors, things like a porosity value. Is it going to be sort of an isotropic or anisotropic behavior of fluid flow? That's all stuff that you can incorporate within those material models. So we've done what we need to here to define that as our engineering material. Now, when it comes to solving and getting some post-processing results out of this, we've got some super interesting ways that we can take advantage of visualizing that information. So if I wanted to trace particles through the system and see how they behave with respect to this balanced or imbalanced flow of water, I can certainly do that, right? So we get some visual examples there. Maybe we're going to vary some of the flow rates or something like that. Now I can start to see, okay, maybe I've got some areas that I would need to adjust. Maybe pressure is a little higher in one channel or velocity is a little bit lower. We can visualize how that's going to work for us here. So we're making some decisions about where we want to go with this design pretty easily just by basing it on some of those preliminary results. Here's another example of how I can visualize some of those results. I can do this in a three-dimensional format as well as some two-dimensional formats like section plots. If I wanted to see right through the center of each one of those channels, what is my distribution of pressure or velocity? Very easy to visualize that stuff here. So just a couple of examples of result types that you might be interested in as we get into post-processing those results, whether it's through a section of the model, maybe on faces of the model, Like I said before, maybe I'm going to take the next step and start to analyze displacements and stresses based on some of these pressure values, for example. Certainly doable. Not only can we get some visual information out of it, we can also interrogate some of the numerical information that's important to us. What we talked about before is I want to try to balance the amount of flow rate through each one of those channels. And we can see that we're kind of getting close to what we're after in that analysis. This allows us, again, to visualize that information and figure out through each of those channels that I've chosen to measure, what is the mass flow rate and are we converging to a particular value? Again, something that's really important, making sure that those results are on track. We cover that pretty heavily in our training for this software module as well. So we've done our experimental setup. We've kind of got an idea of how things are going to behave in this heat exchanger. But now what we come to is optimizing that design. So in the case of figuring out what angle is going to work best for each of those regulator flaps, we can do this with a design of experiments. And this is super simple to set up because I can just leverage all of the variables that already exist within the model. So for example, an angular value for a mate, right? I can use that to actually adjust those components and have it affect the flow rate scenario that I'm trying to analyze. So that's all we did here, is just pick the information that I can use for those variables. Again, same thing here. I'm going to take advantage of goals that give me specific information for what I'm after. So in our case, pressure drop and mass flow rate through the system. I can monitor those as part of my design of experiments study. Now, what we're going to do in the software is actually take those measured values that I've specified, and we want to target something specific. So if I'm putting 60 kilograms per second of mass flow rate into the system, what I want to try to achieve is a third of that for each one of those channels, right? So we're going to set that up as a target value at the locations that I've chosen to measure. So maybe that's a face within the center of each of those heat exchanger models or something like that. We define those objectives, and then ultimately our output is going to lead us to what is the optimum result. So we can see in our optimal scenario where we specified those target values, what is the angular value for each of those regulator flaps that's going to result in the behavior that I'm targeting. So just by filling out a simple table, it's really as straightforward as that. I can get some super useful results, different ways to visualize those. So for example, if I wanted to output matrix charts in 3 dimensions to help me visualize how each of those variables participates in the results, that's all available to you. Very quickly, I can get an idea of how this design will behave and how I'm going to hone in on the most optimal version of it. You can see there that taking advantage of those tools right within SOLIDWORKS is going to make it simple for us to iterate upon that design. So familiar tools to what you guys already know, using things like angular mates, for example, on our design that we've already built in. We're just integrating that within our fluid flow setup to design the optimal version of that product. So pretty straightforward to get started. Again, as I mentioned before, reducing the amount of physical testing that we have to do is really the goal behind this, rather than guessing and checking what is the angular value that I need for each one of those regulator flaps. We do it in the software and hopefully eliminate a lot of steps in the physical testing environment. The second example that I've got for you guys, again, a heat exchanger model, but this time around, we're going to take advantage of integration between CFD and FEA. We want to try to manage the thermal stresses that may occur within this model. So I've got a specific use case of a coil heat exchanger here. So we've got some fins that are hopefully going to regulate the heat well for us. We can choose different material types within the software, but again, we're using our known inputs, right? What is our inlet flow? What is the temperature of that fluid as we begin in the heat exchanger? We can define those. And then what's our outlet conditions, right? Temperature, we're going to leave it open to ambient, essentially in this case. But we've also got another player in here, and that is the air that's moving around this heat exchanger model. So really, we've got a combination of different scenarios. We've got an internal flow within the coil, and we've got an external flow around the coil. that we're going to incorporate in the same study. We want to try to figure out, are we getting the proper temperature of the air and water out of the system that we intend? Again, same story in terms of setup. We're going to use the wizard to help us get there a little bit quicker. So here, if we choose an external analysis, and we use the option for heat conduction, just different physical features that I can add to my study to make it more realistic, those are going to be things that I incorporate here as part of my setup. And as I mentioned before, combining different fluids, if I have to do so, in our case, air and water are both part of the simulation. We're going to incorporate those as part of our initial setup. Now, it does make this really simple in terms of getting information input for how, for example, the air is going to behave around the entire structure. I can just set those up as ambient values. All the air is going to be moving at 70 miles per hour. It's going to be at 50 degrees when it begins within my computational domain. And I can say, what is the initial temperature of all the solid material? Simple setup. Now for the boundary conditions within the coil, again, same type of thing here, just interacting with faces on the model to define what is my volumetric flow in and my pressures out, what are some of the temperatures at each of those locations, and of course, any metrics that I wish to gain insight to, we're gonna define those as goals, right? So air and water, inlet and outlet temperatures are the main things that we're after here. When we get to post-processing, of course, pretty similar to what we looked at with the last heat exchanger model, we're going to be looking at temperature distributions, pretty easy and straightforward to get some of those results either on, section planes or surfaces of the model. Pretty intuitive to help us set that up. Then we can take a look, of course, at flow trajectories. Maybe we want to visualize how the temperature changes as those particles move through the system. That's all pretty easy to do. And then if I need to interrogate any of the numerical results, again, to make sure that my results are converging, for example, what those temperatures are at each location that I wish to measure, all pretty straightforward, and just interacting with the model, right? Picking faces or edges, maybe even sketches that I want to measure from. Now here's the next portion of this. How do I get those results into the FEA environment to help me analyze whether or not there's going to be too much thermal stress in this model and I need to rethink my design? Again, decision-making happens pretty quickly. When I set up my FEA study, it's really as simple as just setting up my properties for that study to incorporate the results from SOLIDWORKS flow simulation. So this could be temperatures or fluid pressures or a combination of both. We just click the options there in our study properties for the FEA setup, and it's going to read in those results to help us analyze the rest of the situation. And if I wanted to combine that with other factors like external loads on the model, that's all doable there because we're now in the FEA environment. So now taking that thermal behavior and figuring out, is that going to incur too much deflection in any of these components where I've got to worry about, stress cracks or anything of that nature? This is sort of the route that we're going to go to figure that out. So we see a couple of post-processing examples there. And then of course, because we're working in the tools that we already know, we can take advantage of things like the simulation reports to help us, put together that information in combination study types like this, where, maybe I've got some outputs that I want to share with other folks within the company, or maybe stakeholders, customers, whatever it might be. You've got a simple, easy to read report there just by using the integrated functionality inside of your simulation environment. Export your report, and it pretty much does all the work for you, as many of you guys have seen me do in the past with examples like this. So we've taken a look at a couple of pretty specific examples here, but really what I wanted to demonstrate there for you guys is the ability that we have to use different types of functionality and make decisions pretty quickly. So really everything that we looked at up to this point had to do with either internal or external flow and some heat transfer situations. But here's kind of a quick cross section of all the capabilities that are available in SOLIDWORKS flow simulation. So if we think about this as, the core add-on for SOLIDWORKS flow simulation, it's able to handle all of the stuff we see here. Compressible and incompressible fluids, internal and external flow. combining CFD and FEA results, even free surface, all that stuff is available to you there. But it's also got some additional modules that you can add into it depending on what you need to achieve in the software. So if you're in the electronics industry, designing enclosures of things of that nature, maybe you've got PCB models that you want to incorporate, electronics cooling is able to gain better insight, use more flexible material types than you can with just the sort of standard package. So think about some of that if you're looking at industry-specific applications. And then, of course, if you're getting into things that's HVAC related or advanced radiation types, where maybe you've got some transparent materials and you want to radiate heat through some of those materials, for example, those are all types of behaviors you can handle with some of the add-on modules for flow simulation. So if you do have any questions about how these work, or you want to dig more in detail with specific applications, you guys can always get a hold of me for more information on that. But hopefully it was a good cross-section of just kind of looking at overall capabilities of the software. So in that last example, we looked at some kind of complex behaviors and really simulating a lot that our design is supposed to be able to handle, both in the fluid flow environment as well as in the FEA environment. How can I combine some of those and make it easy to make decisions as I move along? We can do all that pretty quickly. So if you've got the ability to leverage both of these tools within your application, certainly some handy ways that I can get better results out of it, and really to reduce the amount of physical iterations that I'm doing. Some other industry specific applications, just a couple of quick overview type scenarios here, where maybe I'm looking at pressure drops or dimensioning specific values within a pump system, determining pump efficiency or fan curves. That's all stuff that I can take advantage of. We looked at a couple of heat exchanger models, but if I'm dealing with anything solar related or cooling of any mechanical components, that's all stuff that we can apply here. A couple of interesting applications here too, with things like aerodynamic situations or even noise prediction. That's a functionality we've been able to use for the last couple of years if that's a concern of any of the designs that you're working on with respect to things like, typical external flows and that type of stuff. I mentioned this a little bit, things like mixture processes. If I'm going to, mix different temperatures of fluids, for example, or maybe even mix different fluid types, depending on the situation, you might get into that. Those are a couple of behaviors that, again, I often get questions about. We looked at an example of this, predicting force, right? So I can combine my CFD and FEA results, but even just get a visual understanding of those right within the CFD tool to help me figure out what's the optimal performance of some of these designs, things like an aircraft, airfoil, different aerodynamic coefficients that I can gather from the software. Those are all a possibility there. So huge cross section of stuff. I know that many of you guys out there are using this tool for a wide variety of different applications, and we always love seeing that. And of course, some of those colorful flow diagrams to go along with it. Always interesting to see, kind of, see what other people are doing with the software. So just thought I would give you guys a couple more examples of potential use cases for this situation. Many to take a look at throughout the different experiences that you guys have out there using this software. So take advantage of some of those. Think about how you're going to use this in your application, whether it's something complex like a free surface flow, or maybe just as simple as a conduction type heat transfer problem. Right? You name it, it's pretty much able to handle any of those situations that we looked at here today. So with that said, hopefully that gives you guys some ideas about how you may be able to put these tools to use for you, whether it's a simple or complex type scenario. Many examples here to take a look at. And we're always willing to share more information with you guys here too. So we've been able to interact with our customers that use this over the years, provide a lot of different examples of how you can take advantage of it. If you're interested in learning more about what it can do for you, feel free to get in contact with us at any point. We'll share some information towards the end for how to do that. But we'll start getting into a couple of closing items here and give you guys some ideas for the future. So just to recap what we've done so far, we took a look at how we can integrate these different solutions together, whether it's different simulation tools within SOLIDWORKS or just the CAD environment, and how we leverage simulation. It's pretty easy to understand how that's going to work well in terms of design iteration, reducing the amount of times that I have to incorporate physical testing, which is still going to be a pretty valid point to make. We do have to go through some of that process, absolutely, but we want to try to reduce the cost involved with doing some of that. So take advantage of the software tools to help you do that. And as we've seen, of course, many different use cases that we can take advantage of within the same interface. So with that, again, hopefully you got some ideas about how this tool can work for you. I'm going to go ahead and introduce our next panelist here. He'll give you guys some information about different resources and services that you can take advantage of if you have any interest or need for additional simulation tools. So Damon, go ahead and take it away.
Hey Brandon, thanks for that introduction. Everybody, my name is Damon Tordini. I'm one of the product managers with Hawkridge Systems. If you guys haven't heard, Hawkridge Systems is another engineering solutions provider here that has recently merged with Quest Integration. So Quest and all of you as Quest customers are now going to be part of the Hawkridge Systems family. Just to give you a bit of background, we have been a SolidWorks reseller and support provider for roughly the same amount of time as Quest Integration. The company was founded probably, I think, within a year of Quest. And traditionally, we operated mostly in California and Oregon and Washington. But of course, we've kind of grown a bit over the years. And now that we're welcoming the Quest family into our customer base, that kind of gives us coverage of pretty much all the Western US and Canada, as well as parts of the Midwest. So, the benefit for you guys is that, we now form a pretty large combined team that we hope is going to give you an even better experience just with the support and guidance for all of these tools, than what you're already used to with Quest, which we're sure was at a high level already. So on the analysis side specifically, which is kind of what my responsibilities are focused on, we've had sort of a dedicated simulation team over here at Hawkridge. And we, of course, are familiar with the same SolidWorks analysis tools that Brandon was talking about. So SolidWorks simulation, SolidWorks flow simulation, SolidWorks plastics, the things that have probably been in use at some of your companies for several years now. And we've also, a few years back, expanded into the Simulia realm of products. Those things like Simulia ADKINS, as well as some other kind of niche tools like CST Studio Suite, which is an electromagnetic simulation tool. And so we've started to specialize in some of those higher end analysis tools that really are the only thing out there that can do certain types of problems or certain jobs, and just in an effort to give all of our customers a solution that fits their specific use case. We've got plenty of companies that use both tools. The design team uses the SolidWorks tools in most of their applications, but we have maybe a separate team that uses some of these Simulia tools as well. So we've gained quite a bit of knowledge of how these different types of analysis tools are used in all the different industries. And part of that as well comes from the fact that we have a pretty broad background. Most of us have degrees in either mechanical or aerospace engineering, and we've got 40, maybe 50 years now combined experience. And we owe a lot of this to our customers, who are among many different fields. Those of you who are familiar with the Bay Area probably know there's a lot of medical and high-tech companies in the Bay Area, but of course, we've got quite a lot of experience in the aerospace and defense industry from both Southern California, where I'm based, and the Northwest Seattle area, where some of you might be located. And also we've expanded into doing a little bit of a higher level support and service as well, beyond the traditional tech support that most SolidWorks providers offer. So we do our traditional tech support, of course, but also startup and mentoring services for analysis, as well as peer consulting. So we have plenty of customers who weren't 100% sure if simulation was right for them, and started off by having us do a consulting project for them, using some of the experience we have in things like electronics cooling analysis, and what the right practices are for those types of simulation, what the right assumptions are. And so there are a lot of those cases where we can go beyond kind of the traditional description of what the buttons in the software do, and give you kind of a holistic recommendation of how we think you should run your analysis. And in addition to that, we try to put out a lot of more just general purpose information too via our blog, which we know Quest Integration had as well as we do webinars similar to these, and lots of other YouTube videos and/or blog posts, or bits of marketing content that you'll see in our newsletter from time to time, which are just available to everybody. It's supposed to be kind of a self-help resource to get everyone more familiar with what these tools can do. For example, if you're curious a little bit about these Simulia offerings, we got a couple blog articles that we've written on them in the past couple of years that sort of explain where the line is between those and the SolidWorks tools, so we encourage you to check those out. Of course, we provide all the same technical support that you're used to for all of these SolidWorks products, as well as some of these other things in the Dassault family and related products that we have gotten into. For example, we have kind of a special three-dimensional enterprise harness tool for electrical design that helps map your 2D schematic over to a 3D model. And we do training, of course, just as you're familiar with the training offerings at Quest. Of course, because of the coronavirus situation this year, we've been forced to adapt, and pretty much all of our training has been online for the bulk of 2020. Of course, we'll be looking at trying to add a classroom training back as well in the future whenever we can do that. And all of these offerings, tech support, training, and then the services that we provide are meant to give you sort of every level of guidance, no matter what step of the process you're at. On that note, by the way, probably the most important event of the year when it comes to the information that we try to put out there for you guys is our upcoming Design to Manufacturing Digital Conference. So you might see it called the D2M Conference. Of course, most years around this time, early October is when the new version of SolidWorks has traditionally been released, and we've always had an event to focus on some of those new capabilities. And of course, we'll be doing that this year. But we're expanding it in 2020 more than we've ever done before, where this is now going to be a 3-day online event covering not only what's new in SolidWorks 2021, as well as the latest release of the 3D Experience platform, but we're also going to be hosting 18 live interactive sessions similar to this webinar, where we'll be going really deep into all of the different sort of applications and use cases of the different tools that we offer. So everything from SolidWorks to some of the X-shape or surfacing capabilities on the 3D Experience platform, some of these advanced analysis products, 3D printing technologies that we offer, 3D scanning, and a lot more. So there's probably something for everyone, or at least we hope there is. And this is going to be as close as we can get to a in-person conference, which is what we normally try to do with this event. So we hope you're all able to join us, and at the very least, in the morning sessions, find out what some of the new capabilities in the latest releases are, but also some of the breakout sessions that might kind of be interesting to your specific role or use case for these tools. So if you would like to get some more information about that conference, we've got a little QR code on the screen here that hopefully will take you to the right place. If not, you can go to our website, hawkridgesys.com. We have a page up for this conference specifically. As I mentioned, we have a YouTube channel as well, which is where we post not only kind of short how-to videos, but also recordings of webinars like this one. And we've got a pretty good library of some of these presentations that we've hosted over the years. So again, use that QR code, or you can just go to youtube.com/Hawkridge Systems, or just search for Hawkridge and it'll come up. And you should be taken to a library of, I think we're up to almost a couple hundred videos at this point that cover almost every topic. So again, we're happy to welcome all of you to the Hawkridge family, and we're really excited to find out, what things you guys work on that we haven't seen before. So, of course, we'll be in touch, giving you the right contact information for technical support and everything else. But in the meantime, feel free to check out our website, email us, hawk@hawkridgesys.com.
Excellent. Thank you so much, Damon, for sharing the resources. I know that our customers will be excited to get in and start leveraging some of that stuff. Definitely a lot to be offered there. So let's call it a day, guys. Enjoy your Wednesday, and hopefully we'll see you on the next one. Hopefully we'll have some of you guys join us for the D2M conference. I know I'm excited to see what it's all about and learn some new things this year. Take care. We'll see you next time.